Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 10 from the May-June 2023 Pure Mathematics P3 paper from Cambridge. This is the 9709 syllabus. This is paper 3 variant 2. And here we got a question where we're told about this diagram and this curve y equals x plus 5 times root of 3 minus 2x and its maximum point m. So they told us already that it's a maximum point. Okay, so we know that it's a maximum point, and we're asked to find the exact coordinates of this point M. So what we should understand is that when we have a maximum point, if we were to draw a tangent at that point, you would find that the gradient of that tangent would be equal to 0. It would be a horizontal line. Okay, so the gradient at M is equal to 0. Now the gradient is basically found in an expression, in an equation, by finding dy dx. So we can say that at m, dy dx is equal to 0. So at the point m, dy dx is equal to 0, which means we have to concentrate on finding dy dx. We need to differentiate this expression, and then we can equate that expression to 0. We've differentiated it, and then solving that will give us the coordinates or the x coordinate of m. And then we can continue to find the y coordinate. So we need to find dy dx. That's our aim. So we know that at m, dy dx is equal to 0. Okay, so we have to concentrate on dy dx. So we have our expression y equals, our equation of our curve, y equals x plus 5. I'll write this in index form, getting it ready to differentiate. 3 minus 2x to the power of a half. Now, one of the things that we should be very clear on when we get to P3 differentiation, you cannot differentiate a product of two factors. So if I want to differentiate, for example, if I want to differentiate like a function plus another function, okay, I can differentiate this by differentiating the first function separately and differentiating the second function separately and then adding the two differentials together. But when I have a product or a quotient, that doesn't work. I cannot, if I have a product of two separate functions like this, I cannot just differentiate them separately and, then multiply those two differentials together. It doesn't work if it's a product. So you have to use what's called the product rule. Now the product rule there's like a formula for it, which is given in the formula sheet. But once you've got a bit of practice, you won't really need to refer to it. It's very easy. What you do is you call one product u and the other one v. So I'm going to call x plus 5u, and I'm going to call 3 minus 2x to the power of a half. I'm going to call that v. So I'll differentiate u. So x plus 1, differentiate gives you just 1. If you differentiate with respect to x, and differentiate v with respect to x, here we have to use the chain rule, because you have a function within another function. So you multiply by the power here. So this is, this is 3 minus 2x. Inside the function, that part doesn't change. You take one from the powers, it becomes a negative a half, and you multiply by the differential of what's inside, which is negative 2. Now, when you simplify that, the negative 2 and the half can cancel out to give you negative 1. So you're left with minus 1 over, and now we'll write this, like we know that a to the power of minus n is 1 over a to the power of n. So I'll write this as 3 minus 2x to the power of a half. Okay, so now when you want to find dy dx, we're going to do v times u dash. Okay, dy dx, when you have to differentiate u times v with respect to x, you're going to have v times u dash minus u times v dash. So this times this, so you're going to have 3 minus 2x to the power of a half times 1 minus, so it's going to be, sorry, plus, not plus, minus, plus. So plus there. That's in the formula sheet. I wrote minus, of course should be a plus. Plus these two multiply. So you're going to have x plus 5 multiplied by minus 1 over 3 minus 2x to the power of a half. So let me just simplify this a little bit. This is 3 minus 2x to the power of a half minus, because plus times minus is minus, x plus 5 over 3 minus 2x to the power of a half. So that is the expression for the gradient function. Okay, now we know at m the gradient function is going to give us a value of 0. If I equate this to 0, that will tell us the coordinates of the point m. So I have 3 minus 2x to the power of a half minus x plus 5 over 3 minus 2x to the power of a half is equal to 0. Now I want to get rid of the fraction, so I'm going to multiply both sides by 3 minus 2x to the power of a half. If I multiply this by 3 minus 2x to the power of a half, the square root side disappears. Right? If you multiply it by itself, a half plus half is 1, so you end up with 3 minus 2x to the power of 1, which is 3 minus 2x. If I multiply this by 3 minus 2x to the power of a half, they cancel out, so you're left with minus. Now be careful, there's an x plus 5 here, but it's like there's a minus in front of it, so be careful about this. It's like a bracket should be placed there to be careful there. So now we got 3 minus 2x minus x minus 5 equals 0. So you got minus 3x minus 2 equals 0. So minus 3x is equal to 2. Okay, minus 3x is equal to 2. So x is equal to negative 2/3. Right, so that's the x coordinate for m. Okay, so we have m, we have the x coordinate is minus 2/3. But we want to find the coordinate, so we need to find the y coordinate. So we now need to replace this minus 2/3 back into the original equation, which is x plus 5 times the square root of 3 minus 2x. So this has to be substituted back into the original equation, x plus 5 times the square root of 3 minus 2x. So when we put x equals minus 2/3 into here, what do we get? We get y equals minus 2/3 plus 5 times the square root of 3 minus 2 times negative 2/3. Okay, so that's going to give us y equals, that's minus 2 over 3 plus 15 over 3. 5 is like 15 over, that's minus 13 over 3 times the square root of, and this is going to be 3 minus, it's going to be plus because minus times minus plus, 4 over 3. So let's continue here. So y equals minus 13 over 3 times the square root of, that's going to be 9 over 3 plus 4 over 3, which is 13 over 3. Okay, so in fact that's going to be positive. That's a mistake because that's going to be 15 minus 2, that's positive. I don't know why I put that there. Excuse me for that. So that's positive, right? So now what we're going to do is we're going to try to simplify this. Now we'd like to rationalize the denominator, right? And I know that the square root of a over b is the same as the square root of a over the square root of b. So I can rewrite this as 13 over 3 times root 13 over root 3. And I can rationalize the denominator by multiplying the denominator by root 3, which means I multiply the numerator also by root 3. So I end up with 13 times, now 13 times 3 is what? You have 13 times the square root of, that's 30 plus 9, that's 39, over 3 times, now when I multiply those together, I also get 3. So it's 3 times 3, which is 9. So that's the y coordinate. This is going to be 13 times root 39 over 9. Why do I write it in this form, not decimal form? Because it says the exact coordinates of m. So we found them in the exact form. So there we have it. There's the answer. That's the final answer to this question. The coordinates of the maximum point m. So that concludes this question, and this concludes 10a. Now 10b is a separate question, all about integration, integration by substitution, which I'm going to save as a separate video to be able to classify my videos according to topic. So that will be in a separate video. You'll find that video in the playlist that will appear at the top of the screen at the end of this video. That will be the playlist for this particular paper. And other questions from the topic of differentiation from P3 you'll find in the playlist over here. And questions about differentiation by the product and quotient rules, you'll find questions and examples of that in this playlist. You can subscribe to my channel by clicking on the link at the top. Thank you for watching and see you soon.